Yep, recording. Okay, yeah, you can see a lot of this, can't you? All right, let's get that out of the way. One sec, wrong way. Get out of the way over here. There we go. Perfect. Okay, and you guys can see this now. So let's look at number one, because what is it asking? Number 1 and 2, let's see if we can get them. All right. So difference between populations and samples. Remember that what we're talking about with populations and samples are the sample is a portion of the people in the population. You're going to ask people in the sample questions to try to reflect and inference, a conclusion. You're going to make a conclusion about the larger population based on the smaller group of people you're looking at. Okay. So the parameter is what you're looking at, how old they are, how tall they are. A representative sample, that's good. That's true. Okay. So bias samples, we're going to deal with the random number generator a lot this week. So that's just like a breakdown reminding us of what we're looking at. Okay. So now I look down here and I see that for problems 1 through 3, choose the best response. So we got a multiple choice question. Probably not too much to write down. Okay. So which statement explains why a state government would use population parameters, the number of votes cast in the entire state, okay, rather than samples from each county to determine the outcome of election for governor? Okay. Right. So what this is asking here, and it's worded a little strange, so I'll kind of reword it a little bit. Which statement explains why? Okay. Why the state government uses the population, right? The larger population. And what this is saying is they're counting the votes from the population. They're counting the votes from everyone. Okay. Now, that's what they're going to be doing instead of sampling each. Let's see. You have a sample here from this county. You have a sample here from this county. You have a sample here from this county, and you're going to use all those to find information about the population, right? So they're asking and saying, why is this option better for voting than doing samples and just seeing, well, I'm just going to see, I'm going to look at here, LA County, right? And I'm going to just take some samples. I'm going to ask people what they voted for, who they voted for in their ballots, from LA County. And then this might be, from a state. Maybe this is, Solano County, right? Now, why don't they do this? Why don't they do that for a vote? Maybe in the chat, like, why wouldn't that be fair? Because what is, minus the electoral college, what is representative democracy supposed to do? It's supposed to what? Count everyone's vote, right? Everyone's vote. So this sample here or this option of taking just samples of the population instead of counting everybody, you can't do that because there's going to be methods errors right here. There's going to be a lot with the sample that isn't going to be true. So let's look at this. Modern technology makes it quick and easy to count votes. All right. Not exactly. A sample only represents a portion of the population. A gubernatorial election is too important to decide based on estimates from the sample statistic. Okay, so that looks pretty good. It takes much longer to count the votes in a sample than in a population. That isn't true because it's easier to count these pools of people instead of counting everybody. So that's not true. Not every eligible person votes. That isn't really a nomer for this. That's not really that important. So technology, that's not really why we choose this over that. This one, a sample only represents a portion of the entire population. A governor election is too important to decide based on estimates. And that's the key. I want to bring this up. A statistic is just excuse me. It's not, a statistic is an estimate, okay? It's a measure of a sample to estimate the population data, right? We don't want to estimate who should be a governor. We want to actually count who wants to be governor. So this is why we would choose this one, because a sample only represents a portion of the entire population. We don't just care what these people think. We care what everybody thinks, okay? And how you group them in those groups, that's called gerrymandering in a lot of ways. There's something that'll be illegal very soon, I'm sure. You may have heard of gerrymandering. Look it up if you haven't. Gerrymandering is why we don't want to do this, okay? It's related. I'll just say it's related. Okay, so it's too important to decide based on estimates. We're not going to use these estimates. We're going to actually count everybody. So this would be, for number 1, we're talking about B. Okay? You might have one like that way off when we have like the, quiz, the last quiz for this unit. Okay? So let's look at number 2 and see if we can be as successful with it. All right. Which statement explains why sample statistics, so sample, remember, it's always between the sample and the population. So sample statistics are used by the media to make predictions prior to a presidential election. Why do they do that? So people will keep watching, right? And they give input. They need something to say on who do they think is going to win and talk about it. But here's what we'll look at. Why do they use samples to guess who the president is going to be? They look at these people and ask them the question, and they see, well, does that say that, this person's going to win over that person? Okay. Percentages are difficult to compute with large numbers. No. I could find the percentage of, 10 million out of 32 million. Big numbers don't really make a difference. Sample statistics are more reliable than population parameters. Well, that's not true because a population parameter is asking everybody. That would be asking everybody, but we're not asking the whole population. We're only asking the sample. So I don't think that's more reliable because you can ask everybody and be the most reliable, but that takes too long, usually. All right, members of the Electoral College determine the outcome of the presidential election rather than popular vote. Yeah, but that's a red herring. That's like a distraction. It would not be practical for the media to determine every person's opinion prior to the election, right? It wouldn't be practical. It wouldn't be practical. Could they call every single person in the U.S. and try to get every single person to tell them who they're going to vote for? No way. No way. So instead, it's not practical to ask everybody. They can't ask everybody. So they're just going to ask these people. And that is what statistics are. That's why we got to be real careful because who's included in that sample? That's the next section. How are they counted? Does that reflect the population? Okay. So this is why for number 2, for 1.2.1, we're going with D. It's not practical. All right, you guys, I see some nodding of heads. We're good then, I think. Okay. Thumbs up, sideways down. You see the logic I went with it? I mean, I'll probably even make a multiple choice. All right, good. Thanks for the feedback. All right, now we're going to jump over to the next section. So I'll just keep recording this. That last problem was 2B. Sorry, 2. The answer is D. So we did number 1 and number 2 in 1-2-1. So we're moving on from 1-2-1. Okay, because we are short with time and I want to spend it on this. Yeah, we only have 10 minutes. I think we could do one of these. All right, so tomorrow we'll look over more of these before we do the activity. In fact, let's count on that. So maybe I'll put it open for this. Any numbers we want to look over, and if we don't get to all of them, then I'll record another video tomorrow and go over them. So tell me in the chat. We're looking at practice. Remember, the problems are always in practice. It's practice 1, 2, 3, and it was 1 through 7. So who has one they want to see? Maybe some of the first ones. 3, good. Anyone else before I get started on 3? Oh. Okay, that's from the last one. So we'll look at 3. All right, hey, no big deal. We'll look over the rest of this. Honestly, I'll say this. We have the sampling activity tomorrow, number 7. Okay, I have 3 and 7 right now. We have the sampling activity tomorrow. We have one more lesson after this on Thursday. And then we're going to start working on that project where we're going to have looking at sampling bias, looking at incorrect statistics. So really, we have this material with Unit 1. We have the rest of this week. Maybe a little more, but we'll see. Okay. But just know that we're rounding and closing up all of our statistics pretty soon. Okay, so stick in there. Stick with it. All right. Let's look at this. We got a request for number 3. Let's look. All right, so what we're trying to do is identify which type of sampling is being used. Okay, simple random sample, cluster sample, systematic, or stratified. Convenience, I'll bring up in a different way, but convenience sample is when it's incorrect. A convenience sample is saying, I want to see what all the students in West Campus, what kind of food they like. But a convenient sample is when you would only ask the people right around you, where it's the most convenient. So if you were at lunch and you just asked your friends, what's your favorite food? That's not good enough, right? So a convenient sample is when it's convenient. It's not good enough. Okay. There could be more than one. Oh, that would make it harder. All right, so I'm going to get all the samplings ready so we can see them. We got simple random sample. We got cluster sample. We have stratified. We have systematic. So we're going to look at those 4 options as we go. A television station wants to predict the results of a referendum on legalizing gambling. So referendum's like a proposition, okay? So like when you vote for propositions. And let's see, the television station randomly selects 8 precincts and conducts exit polling of all voters at each of the selected precincts. So this is how it works. You have a county, right? You have a county, which, this is the county. And then within it, there's precincts. Precincts are just, it's just what area you're going to be voting for. So maybe that's 1, 2, 3, and 4. So the county might be broken up into 4 precincts like this. Precincts is just a boundary that is around you where you live. If you live here, you're in precinct 3. You live there, you're in 2, and so on. So now that I'm looking at that, what they're saying is the television station randomly selects 8 precincts and conducts exit polls of all voters at each of the selected precincts. All voters in the selected precincts. Randomly selects 8 precincts. Okay. So right off the bat, I need to add some more. There's 5, there's 6, there's 7, and 8 is small for some reason. Okay. So we got our 8 precincts. And what this is saying is you randomly select one of the precincts and then you take everyone in that grouping. So let's see. The 2 that really stick out here is these 2. Cluster sample and stratified sample. Because look how similar they are. Cluster sample, divide objects into naturally occurring clusters. That seems like precincts. Use the random number generator to select the cluster. That seems like what they did. They randomly selected it. Within the selected cluster, use the RNG to select sample objects. They, instead for this, just said, we're going to take everybody in that precinct. Okay, so that is slightly different, but it might be close enough. Stratified, divide population into subsets with similar characteristics. Yeah, they live near each other. Use a RNG to select objects from each subset until sample complete. This is not what we want, though. Right? So this stratify would be this. Divide them up, right? And then you go to this precinct and you take a random number generator to select some objects there, then 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 there, and you keep going till you fill up all your votes. That's different, right? That's not what they were asking. When I look at what they were actually saying, right now it seems more like a cluster sample. And let's see if that makes sense now that we look at it. Okay. So it says, a television station wants to predict the results of a referendum to legalize gambling. The television station randomly selects 8 precincts. Okay. Divide the objects into naturally occurring clusters. We got all the precincts. Use a RNG to select the cluster. So they select randomly, select 8 precincts and conduct exit pollings at all voters at each of the selected precincts. Okay. Okay. So there's probably even more precincts than this. They're only selecting 8 of them. And so there must be more. Must be broken up a little bit bigger. But what they're saying is now they're broken up. Now I'm going to randomly select one of my precincts here and get all the votes from that precinct. So I'm going to say for number 3, the closest thing it is to is cluster. The only difference is when you randomly find your cluster you're going to look at number 9. Then you would use the RNG, random number generator, to pull out the votes that you're going to be looking at. Okay, you're going to look at these votes. Instead, what they said is, let's go ahead and look at everybody in precinct 9. But cluster sample is the closest thing I could see. Okay. And I see I have 5 minutes left. I don't like Mondays because I can't stop and ask questions about it that much. I can go on to number 7 if there's, but ask me number 3. I'd rather have this one complete before doing number 7. We could do 7 tomorrow. So does anybody have confusion? This is just kind of tricky, right? Is this just kind of tricky? It's just tricky. But remember, you have 4 different options. And maybe this will help. Let's do this. Get out your notes from 1, 2, 3, and let's just kind of make even some symbols to help figure this out. Okay. All right. So, oh, I see. Okay. Here's what I'm going to say. For cluster that we just did, right? We divide up the objects. Then you're going to select one of the clusters. This cluster, right? You're doing that with a random number generator. Then, from that cluster, you use a random number generator to get your votes. Okay? So I think it's just going to be helpful to realize that cluster and stratified are really similar, because for stratified, I'd also make these naturally occurring divisions, divide it into naturally occurring subsets. But then I would look at this. We're going to use an RNG to select objects from each subset until you're complete. So this is more like this. It would be random number generator from this one, right? That'd be 1. Then a random number generator from this one. That'd be number 2. Then I would go to the next cluster, and I would do a random number generator, and that'd be my 3rd option. You see? So the difference is here, you use a random number generator to even figure out what cluster you're looking for, and you take a random number generator to take a vote out from that, or 3, or as many votes as you classify. Right. That might help. That might not. The good thing is we have 2 that are related by grouping. These 2 we are related by grouping. This one up here, simple random sample. You just make it. I do this. Think of it like this. You're going to just make a list. You're going to number them, right? Just going to make a list. Okay. So just make like a little image of a list, right? And then what you're going to do is you're going to use a random number generator. Once they've been numbered, use the random number generator to pull out your sample. Sometimes if you just have like a little icon, it helps you organize in your head. Is this helping a little bit with that? Just have a little icon. Some it helps. If you're not visual, maybe not always. But we have cluster and stratified. Both are about grouping. Simple random sample is just listed out, and random number generate, pull out your values. So I might get the 5 items, I need 3. My random number might be, I might pull out a 5, random number generator pull out 2, random number generator pull out 3, and those would be my 3 I would use. All right. Tomorrow's activity will put this into work. Okay. Last thing before I sent you out, systematic sample is a little bit trickier. The way that I would say with this one, okay, right. So this one starts with a list too. So we have like 2 lists, and we have 2 clusters really. I should have put them on the same page. 1, 2, 3, 4, 5. So make your list just so you kind of have a visual. And then this one's different. This one's the most complex. Okay, so maybe even just write that. Most complex. Okay, put them in natural order. Find a starting point. Okay, so we have start with a random number generator to know that we're going to start here. Start. So your starting point, I'm going to put point. Starting point. Use your random number generator to find your starting point. You have to figure out the increment, and the increment, maybe this increment equals, let's see, steps to next selection. That's not easier, but what I was thinking is you have these little, almost like the little abridged kind of images. Then in your head you could look at them quick and kind of start to make more information connected. I hope that's a little bit helpful. All right, I'm letting you out late already, aren't I? Oh God. Mondays are always frustrating. I'm sorry I couldn't ask more questions. We got through it though. Yeah. Tomorrow, come with your questions ready for the sampling exercise. And we're going to have an interesting assignment tomorrow in class. Very, very short lesson that'll wrap it up. And then we'll spend the week. We'll be good, I think. All right, stick around if you have any questions. Otherwise, you guys are dismissed. I'll do number 7 on in tomorrow. Okay. All right, guys. Have a good day. See ya. Take care.